First and foremost, I would like to say thank you very much to everyone who is tuning in for today's webinar. My name is Anas. I'm from CYBERNET Systems Malaysia, and I've been working here as an application engineer for almost 2 years now. So today's webinar is going to be about the drop simulation for electronics products using Ansys. Essentially, this webinar is going to be revolves around the importance of drop tests for electronics products and how it can be done using computer simulation instead of physical testing. Okay, so here is the agenda for today. First, I would like to introduce our company a little bit. And then next, we get into the little bit of the introduction of CAE. Essentially, what is CAE and what is the advantage of CAE? Just going to explain a little bit about what is it and what it can do, essentially. Next, I will talk about the Ansys as CAE solutions provider. We will get into what Ansys is and what solutions it can offer. And then from there, we continue with the introduction of Ansys LS-DYNA. Ansys LS-DYNA is actually a perfect solution for a drop test simulation. Therefore, we are going to focus mainly on this. Then we will go through some of the examples for a drop test simulations. And then finally, before we wrap things up with the Q&A session, I will be going to do a quick summary for today's webinar. And we'll introduce you a little bit to our service here in CYBERNET Systems Malaysia. Okay, now let's start with a little introduction to our company. Established in 1985, CYBERNET System has been providing CAE solutions and IT solutions through product sales, contract analysis, consulting, and software development for over 30 years now. We have developed partnership with more than 20 companies, so mainly in the United States, including Ansys, Synopsys, and Symantec. The sales subsidiaries of CYBERNET System consist of CYBERNET China, CYBERNET Taiwan, CYFAM, which is based in Korea, and of course, CYBERNET Systems Malaysia. So here, as you can see, the CYBERNET System has been working with numbers of group companies around the world for both sales and also development. Our development subsidiary includes Noesis, MapleSoft, Symmetrics, while our sales subsidiary, like I mentioned previously, consists of CYBERNET Japan, China, Taiwan, Korea, and also Malaysia. Now a little introduction about CYBERNET Systems Malaysia, Sendirian Marhad. So CYBERNET Systems Malaysia was established in November 2018 as the fourth subsidiary in Asia. So our office is located in Kuala Lumpur and has been around for more than 2 years now. So our business here mainly revolves around CAE solutions, IT solutions, and also professional services. Our partners up until this point in time include Ansys, Synopsys, and also others. Okay, now like I mentioned before, CYBERNET Systems provide all sorts of solutions to meet our customers' needs. Those solutions are CAE solutions, which give a total support for CAE utilization in various fields. Main application areas included under the CAE solutions are mechanical systems, fluid systems, control systems, optical, electrical systems, and so on. Then we also provide the AR/VR solutions as well, big data solutions, IoT and digital twin services, IT solutions, and also engineering services. I will talk more about the engineering services provided by CYBERNET Systems Malaysia at the end of this webinar, so stay tuned with us until the end if you want to know more about our engineering services here in CYBERNET Systems Malaysia. Okay, now let's talk a little bit about computer-aided engineering, or CAE for short. So what is computer-aided engineering? In essence, CAE is a usage of computer software to aid engineering analysis tasks. So it is a term used to describe the procedure of the entire product engineering process, from design and virtual testing all the way to the planning of manufacturing. Now, unlike many people think, CAE actually goes beyond the analysis and development stages. CAE actually defines the entire product engineering process from initial design creation, virtual testing with sophisticated algorithms, all the way to the maintenance process. Here we talk about the something like a digital twin, for example. So it allows a dynamic testing process to support the engineering by numerically simulating the physical properties of a product in various conditions and environments without having the need to make a physical prototype. So basically what it does is actually mimicking what happened in the physical world or real world, but instead doing it in a computer, and therefore can save a lot of time and also effort during the development process. In the context of CAE, most commonly used simulation analysis type include something like a finite element analysis, or FEA, computational fluid dynamics, or CFD, optimization, digital twin, and so on. Next, we move to the advantages of CAE. So essentially, why do we need CAE? So basically, with the shortening of the life cycle of a product development and the pursuit of more compact and efficient product design, engineering becomes more and more difficult with just pure physical experiments. So like I mentioned previously, computer simulation technology enables virtual experiments or virtual prototyping be done on your computer. This will ultimately save the deployment time of a product and therefore save the overall cost and ultimately produce a more reliable and better quality products. With CAE, the amount of prototype testing can ultimately be reduced. This is because a computer simulation allows multiple what-if scenarios to be tested quickly and effectively from your computer. One example that I like to mention many times previously is Dyson. So you might heard of Dyson before, yes? That one company that make the fancy vacuum cleaner. Yeah, so earlier last year, Dyson answered this call from the UK government to help to curb the situation of the COVID-19 pandemic by developing a mechanical medical ventilator. So traditionally, the design and development process will take a huge amount of time. But in the case of Dyson, by utilizing CAE, in a matter of weeks, Dyson managed to design, simulate, and also optimize their ventilators, and then ultimately cleared to be produced the next couple of weeks. So now they achieved this by eliminating the need to build a physical prototypes for multiple designs. So instead, they optimize their design using CAE, and then out of their many designs, they come up with the best design, and then continue with the physical tests for that particular design. So for me, this is the prime example of what can be achieved with CAE. So basically, as showcased by Dyson here, you can literally help to save lives with it. Yeah, so next, with CAE, you can also, the risk assessment and also performance implication of the design can be identified earlier on. So CAE can provide these performance insights earlier in the development process when the design changes. I'm sorry, when the design changes are less expensive to make. So imagine if you are designing a product, and then later on when the products are at the verge of the production process, you identify a major flaw in the products. The design change that you have to make at this particular stage will have a big impact in terms of cost. So with CAE, you can simulate almost any possible condition under any kind of worst case scenarios to identify the product performance earlier on in the design stage. Okay, now let's continue with the introduction of Ansys as CAE simulation software provider. CAE has been around for a long time now. Since the beginning, Ansys has been providing one of, if not the most powerful and also advanced CAE software of them all. So Ansys specialized in simulating a highly complex problem, and also delivering accurate results while providing an easy to use operating environment. So yeah, a little bit of background regarding Ansys. Founded by John Swanson in 1970s, Ansys Inc. is a global public company based in Canonsburg, Pennsylvania, which is in the United States. It develops multi-physics engineering simulation software for product design, testing, and operation. So as you can see on your screen right now, those multi-physics include almost every conceivable physics analysis that you can think of, ranging from a simple structural analysis all the way to a system simulation. So for 50 years now, Ansys has been the class-leading multi-physics simulation software provider. Due to that fact, Ansys now has been used worldwide with over 45,000 global customers. Due to that fact as well, Ansys is also used in a wide range of industries, including automotive industries, electric and also electronics industries, aerospace industries, and many, many others. Yeah, so as I said before, Ansys provide multiple physics simulation for every types of needs. So now those solutions include mechanical solutions, fluid solutions, electronic solutions, solutions for designers, which is mainly for CAD user, and also some additional options. So essentially for mechanical solutions, the analysis included under these particular solutions are static structural analysis, dynamic analysis, impact analysis, thermal analysis, fatigue analysis, topology optimizations, and so on. Under the fluid solution, you can do something like a general purpose thermal fluid analysis, or something like a rotating mechanical fluid analysis for those who are involved in a turbo machinery industries. And then with the fluid solution as well, you can simulate something like a resin flow analysis. And then for the electronic solution, the analysis included under this kind of solutions included the electromagnetic field analysis, signal and also power integrity, electromagnetic interference analysis, and so on. And then next, Ansys also provide a design solution, which is mainly for designers or CAD users. This is done using one of the Ansys product called Ansys Discovery. Then for some of the additional options that Ansys offers as well is mainly included something like a parallel computing modules for faster solution time, material data selection library, and so on. Okay, now with all that said, let's dive into the Ansys LS-DYNA. So we are going to go through what is Ansys LS-DYNA, what it can do, and some of the features available, and so on. So let's get into it. First, an overview of Ansys LS-DYNA, or should I say the overview for explicit dynamics analysis. LS-DYNA is a general purpose finite element code for simulating the response of material to in short periods of severe loading. So it is the most commonly used explicit program for solving a highly nonlinear problem, transient and dynamics problem, using explicit time integration. So I said explicit couple of times now. So implicit and explicit actually refer to the two types of time integration methods used to perform a dynamics simulations. So we are not going into too much details of the differences between these two, but basically explicit time integration is more accurate and efficient for simulation involving shockwave propagation, large deformation and strains, fragmentation, and also breakup in a short period of time. So the key thing here for explicit simulation is that they are all happen in a very short durations. The explicit code are very large and also general, and they can cover a huge range of application. So if you take a look at the diagram here, the explicit solver typically there for short duration events. So when I say short duration events, I mean things that last a second or less, basically. Therefore, events such as drop tests or a ballistic impacts, moving all the way to the detonation or hypervelocity impacts where events happen at thousands of meters per second. So these kind of extreme events, explicit dynamics will be the way to go. Like I mentioned previously, LS-DYNA can cover a huge range of applications in a wide spectrum of industries. Therefore, when we talk about any simulation or analysis that have the high degree of non-linearity or events that happen in a short amount of time, we are looking at applications such as metal stamping, crimping process, piercing, shearing, spin forming, and so on. So actually, this kind of application involve a large deformation and also large plasticity, which is a very material non-linearity that happen there, which can be difficult or hard to be analyzed implicitly. It can be done, but the challenge would be far more significant comparing when you do it using the explicit methods. In the industries such as automotive industries, again, we are looking at high nonlinearity events that happen in a short period of time, such as crash tests, where the nonlinearity context between surfaces is very hard to be determined if you are to do it implicitly. Or maybe something like the airbag deployment. So such event that happen in a matter of milliseconds, and so on. So at this point, I believe you get the idea of what kind of application that is most suited for explicit dynamics approach. Now, of course, drop test is definitely one of the analysis that fit right in this method of analysis. So that's why we have this kind of introduction beforehand. When we talk about drop test, we need to identify the structural behavior during and also after the impact. So after our devices hit the ground on the floor. So that means any sudden contacts or any large deformation or large plasticity that happen rapidly need to be taken into account. So this kind of analysis, explicit dynamics, is actually the best way to go. Okay, now these are some of the animation for the application that I mentioned in the previous slides. Say, for example, this hot forming here is one of the manufacturing process that is very suitable to do analysis on. In this case, we need to find the material thinning or spring back effects. All of these factors need to be identified in order to properly design the mold for the forming. And then the rest of the example here, spin forming, crimping, and rivet piercing pretty much carry the same sort of challenge, where the material non-linearity needs to be observed and also need to be identified so that the proper planning can be done before the actual physical process can be conducted. These are some of the animation examples for the analysis for the automotive industries, to be more specific, where the safety is regarded as the top priority when it comes to designing any sort of automotive vehicles. So therefore, having the ability to do simulation such as this rear end crash simulation, or something like this one, the roof crash test here, can be really helpful in determining the overall design performance of the automotive products. And then for the consumer products, again, we are taking the advantage of the ability of explicit dynamics to do analysis in order to understand more about the product performances. So drop tests of a different kind of product, whether it is a packaging drop test. So essentially, we would like to simulate the drop during the transportation process, for example, or even something like the cell phone drop test, which is something that has been done quite frequently, I should say, in recent time. So manufacturers are trying to make their product as rugged and as impact-proof as possible, so that the marketability of the products can be improved overall. So in some cases, devices such as smartphone is being used in all sorts of conditions. Some might be used during the outdoor activities such as running or cycling and so on, where accidental drop, the risk of accidental drop may occur more frequently. Therefore, this kind of analysis can prove to be very valuable for companies or manufacturers out there. Now let's touch a little bit about the material models available with LS-DYNA. When we're dealing with a problem with a high level of non-linearity, it is important that we specify the materials that we are using accurately. In cases such as a crash test or the material plasticity need to be defined in order for the crash results, where the crumpling of the structure deform permanently to be captured accurately. Fortunately for LS-DYNA, LS-DYNA has a huge variety of material model that you can choose from in order for you to do analysis from a wide range of applications. So these are just some of the material models that is available in LS-DYNA. So for more details of the material model in LS-DYNA, you can go to this website right here, where the manuals for the material models can be downloaded for free. So inside those manuals, you can go through each of these material model, and then you can study which kind of material that fits your needs in your particular applications. There are so many of them. To be quite honest with you, me myself does not go through all of them yet. So it is a learning process. So if you choose to go to this website here, you can look through all of the material properties and also some contact properties as well available in these manuals. Okay, now with that being said, let's move on to the one specific application that we all might be interested in. Now let's take a look at the drop test simulation, specifically the drop test for an electronic devices. So now electronic devices can be found everywhere nowadays, basically. So from everyday consumer products to the specific tools used in businesses. So electronic devices is absolutely everywhere. We cannot run away from it. Actually, we cannot live without it, actually. Therefore, it is only natural that manufacturers or companies has been investing more towards the overall performance of the products. not only from the electronics performances, but also on the structural performances as well. Okay, now one of the common failure for electronics consumer products in everyday use is actually the accidental drop. In consumer products, accidental drops can be caused during rigorous handling, during distribution, or transportation, I should say, or in a daily usage of the product itself. Like I mentioned previously, when you are doing outdoor activity such as running or cycling, those can increase the risk of accidental drop as well. According to statista.com, in the survey of the most common causes of accidental damage, according to the end users, in United States in 2018, 74% of the respondents reported to dropping their phone on the ground, making it the most common cause for accidental drops, followed by the dropping out of the pocket. So this kind of survey indicates that accidental drops of one of the most used electronic devices happen more frequently than most people expected. Yeah, so it might not happen to us, but out there, these kind of accidents happens all the time. So when we talk about drop tests, actually drop testing evaluates a product's ability to withstand the impact from being dropped. Pretty straightforward. Since the accidental drops are likely to occur during the product's lifetimes, it is important that a product be designed to, at the minimum, define number of these impacts. So objective of drop test is to inspect the failure and damage of the equipment under the test caused by free fall, and also simulate the scene of falling during product transportation. So for drop tests, several standards has been established as a guide in order to fulfill the requirement of the drop test. Some of the standards available for drop test specifically include something like GBT 2463, which is part of the international standard IAC 600-68, and also the military standard MIL-STD 810G, which is used in the USA military standards. These standards generally share the same methodology when it comes to the product orientation during the drop test. That includes some corner drops, edge drops, and also face drop. The differences may come on how many drops requires for each position of your devices. So you can look into these standards if you want to learn more about what kind of standards being established for specifically for a drop test. Okay, now there are some limitations when it comes to do a physical drop test. While drop testing validates that a device design can withstand a limited number of impacts of a specific intensity, it cannot ensure that a device will survive all of those drop situations. So several limitations to physical drop testing include when drops exceed the product specification limits, which may cause the product to fail physically or functionally. And then another limitation is the cumulative damage from each successive drop. And also another challenge would be the environment factors such as fluctuating temperature. So these kind of limitations are not going to be a problem when it comes to do virtual testing. So in virtual testing or in the computer simulation, temperature can be set as constant, or you can set the temperature at which level that you want. And then you can set that there will be no fluctuation at all. For example, now the amount of testing you can do virtually using the same design as well is basically limitless. So basically, the virtual setup will be the most ideal setup for a drop test, especially when we are talking about different orientation that involve different design points. So if we go with the virtual testing, all of this limitation is generally not going to exist. Okay, next, when it comes to a drop test, several factors or variables need to be kept in check in order to properly evaluate the results or of the drop test later on at the end of your experiment. So there are various variables of drop testing effects that affects the severity of the test, including the height of drops, essentially meaning the device can be dropped from varying heights. That's straightforward. And then surface material as well, to which the unit's been dropped, such as plywood over concrete or vinyl tile over concrete, or even when you drop the device over a pure concrete, for example, or even steels. So these kind of parameters need to be taken into consideration as well. Then, of course, the temperature where drop tests can be performed. Drop tests can be performed at temperature above the operating temperature or of the device, or just set at the room temperature. Again, all of these settings can be incorporated inside the simulation environment very easily. So there is not going to be any problem when it comes to specifying all of these parameters inside Ansys LS-DYNA. Drop height can be specified with the inclusion of standard Earth gravity quite easily. And then the surface material can be modeled, and different surface friction as well can be specified. And then the environment temperature of the drop test as well can be set to whichever temperature that you desire, depending on what application that you are trying to simulate. So one of the advantages of Ansys LS-DYNA is that it is relatively easy to use. I'm not going to say it is absolutely easy to use. I say it is relatively easy to use because of these features such as this drop test wizard. Now this drop test wizard allows the users to easily set up the device orientation, the target orientation, the boundary conditions such as drop height, impact velocity, and so on. So all of these, in fact, all of these parameters that I've mentioned in the previous slide can be specified or can be set quite easily using this particular drop test wizard. So essentially the workflow is that you import your geometry into the Ansys environment. Then you set your desired configuration or desired parameter inside this drop test wizard. And then it will automatically set up these conditions for you. Then all that's left for you to do is that you set up the proper meshings, you specify a proper connections, and then you are good to go. You can run the simulation, then you can see the results of your analysis. This more or less help reduce sometimes when you start to involve a large number of different designs. So when it comes to 10 different design points, this kind of feature will prove to be really helpful to do or to set up all of those design point analysis environment very quickly and very easily. Okay, now that's basically cover the general overview of drop tests and the should I say motivation behind this kind of analysis. So next, let's take a look at several examples for this kind of drop test simulation using Ansys LS-DYNA. Okay, now the first one here, we have the example of LCD packaging drop test. Like I mentioned in the previous slide, accidental drop during the product transport and also product distribution being one of the most common causes for product damage. I'm sorry. Now, for that reason, drop testing is becoming a very common part of ISTA, or International Safe Transit Association testing procedures, because this effectively allowing the product packaging engineers or designers to thoroughly examine the effectiveness of their package cushioning, for example, and also ultimately verify its ability to protect the products packaging materials, closures, and other critical design attributes when exposed to all possible drop test orientation. So as you can see, this kind of model use different kind of material to present each of the component of the assembly. So first we have the tray, which is where the LCD sits in. Now the tray can be made out of different sorts of materials. Some might be made out of plastic, some might be out of the fibrous material, and so on. And then the tray is being secured in place by this EPE foam. There are several ways for you to model EPE foam-like material in Ansys LS-DYNA. Either you use the LS-DYNA material models that I've shown you previously, or you can just go straight into the Ansys engineering data and specify the foam material properties directly inside there. You can also choose to do so. And then the cardboard is modeled for everything else to be placed in. So again, the cardboard material can be modeled inside the simulation environment. Either you do it in the way like from microscopic perspective, where you simply just assign the anisotropic material properties for that cardboard box, and therefore it will give you the general idea of how the structural integrity of the cardboard box will perform. So the results of the drop test essentially show the stress propagation throughout the entire assembly from the cardboard all the way to the LCD. So from here, you can essentially evaluate the cushioning of the EPE foam, so whether or not it is sufficient to dissipate energy that coming from the impact force to the LCDs at a particular drop height. So from there, you can start to modify the design of your foam. Maybe you can start to modify the way you arrange your LCD in your packaging and so on. So a lot of data that can be gathered from this kind of analysis, which allow you to do a lot of adjustment or modification on your packaging process, essentially. So this is essentially one of the I see importance of drop tests being done. So next we move to another example, which this one is about the iPad and also a protective case analysis. So when we have, usually when we have a smartphone or when we have a tablet, we are going to slap on some protective case in order to protect it even more. So this kind of analysis essentially shows you that such case as well, you can include the protective case into your analysis and then see how it performs, and then see how much does it affects on the device as well. So this kind of analysis, if you are talking about physical testing, it's actually pretty common, generally speaking. So you can find such experiment being done even on YouTube nowadays. So it is very common test that you see here, where you drop a device, specifically a smartphone. So this kind of experiment can be done obviously in the LS-DYNA. Essentially, this analysis was done. We want to sort of compare the results from the simulation of using an Ansys LS-DYNA to the experimental data. And then the configuration of this analysis is, as you can see on the screen, it's 1.8 meter drop height. So at the bottom right-hand corner. So this is going to be a corner drop setup. So in this particular analysis, we would like to understand the influence of the angle and also the adhesive failure of the device itself to the resultant acceleration of the device. So what we want to do here essentially that we would like to evaluate the shock on the device that we drop or upon impact. So we are evaluating the performance. In the case of the protective case analysis, we are evaluating the performance of the protective case to optimize the weight. So based on the figure, as you can see, based on the figure in the physical experiment, we place this accelerometer in these two positions right here. Actually, there are like a specific principle of which point that you need to put the accelerometers. Essentially, you put it at the center of your mass. So in this particular case, we put at that two particular point. And then inside Ansys as well, we can choose those very specific points to measure the resultant acceleration. And therefore, we eliminate this position of the accelerometer variable, so making it more easy to compare between physical tests and also simulation results. Okay, now as you can see on the figures down there, what we do here is that the deviation of the impact angle would change about plus minus 5 degrees from the baseline. So the baseline impact was done by experiment, and then the angle, 5-degree angle configuration were done using LS-DYNA. So that's why you see a quite large gap between experiment and also LS-DYNA. It is because it is completely a different test altogether. So from the results, the influence of angle or drop angle, I should say, in X, Z, and also combination of X and Z axis was around 439 G. G as in the resultant acceleration. Therefore, from here we can say, or we can conclude, that the impact angle of this particular drop has a quite significant effect on the drop test results. Specifically, if we are talking about this resultant acceleration, the difference between changes can be quite significant. Now, as for the influence of adhesive failure, now adhesive failure essentially means the failure of adhesive between your devices. So some of the components on your devices was glued together using some kind of adhesive. So we incorporate some sort of adhesive failure into our experiments or analysis, and then we see if there is going to be any kind of results in the resultant accelerations. So as for the influence of the adhesive failures, configurations that is being included in this analysis include device with no glass, so we get rid of the glass altogether. And then the next one is we use tight interface, meaning that the connection between components is essentially bonded together, so there will be no separation at all. And then the rest was set to have a specific adhesive failure threshold. So some may fail at a specific yield stress, for example. So after we set all of this, from this analysis, it was shown that the influence of adhesive failure was around 9 to 10% differences. Therefore, in this particular case, we can almost say that the addition of the assembly does not influence towards the overall structural integrity of the device by a huge margin. It does have some influence, but not by a huge margin. Next, we go into the optimization of the protective case. So for the original case, I'm sorry. The original design is weighing at the 349 grams. So with the claim protection height between 1 meter to 1.8 meter. So for the original design was optimized by cleverly redesigning the internal of the case and remove some of the unnecessary materials that does not support does not serve as a support during the drop events. As the results from that, the optimized case managed to have a weight reduction to less than 200 grams with this same protection height of 1.8 meter. So from the figure there, you can observe the elastic recovery from the rubber-like material of the case, which is the kind of material that we are using to model the cases. You can model such hyperelastic material inside Ansys LS-DYNA environment. So you will have no problems modeling such kind of material to use for the protective case. So from the figures there, you can observe the protective case actually absorb the significant amount of energy, keeping the device from shattered. So when you compare the figures on the left there, compare when you have the protective case and also when you don't have the protective case, you can see what kind of damage is being dealt to the devices. Okay, now finally for our final and third example here, we have the example of the PCB drop test with trace mapping. Now I will talk more about the trace mapping in the following slides. Essentially in the consumer products, one of the most expensive damage on that particular product would be the damage electronics components or the PCB of the products. Essentially, this kind of realization triggers the development of electronics consumer products, not only on the aspect of the electronic performances, but also the structural performances as well. Due to this fact, there have been some work done to adopt new type of material used for the PCB and its component. So essentially, we are looking at a lighter and stronger material as we progress forward. So for this particular example, we are just going to focus or showcase one of the features that is recently available with the Ansys LS-DYNA, which is the trace mapping function. Again, we will go into the details on the next slides. So generally, PCB or printed circuit board comprises of a flat sheet of the insulating material and a layer of copper foil laminated to a substrate. Okay. For a multi-layer board, conductors on different layers are connected with something that is known as vias, which is a copper-plated hole that is function as electrical tunnel through the insulating substrate. So most commonly used material for the substrate is the FR4, with other material as well has been seen being used depending on what kind of application that you are doing. Okay, now let's talk a little bit more about the trace mapping. Now, for the approach used for this particular example here, we go with the trace mapping approach. So Ansys provide a solution for modeling PCBs and electronics components with multiple levels of fidelity. So if you can see on the diagram here, you can either use the homogenized approach, where essentially you lump together the entire board and then use equivalent material properties to represent that particular PCB. Or you can go on actually model the geometry, 3D geometry of the traces and the vias. So this is what we call as trace modeling, where you actually model the geometry of the trace and via. So sit somewhere between those two is a sweet spot where the trace mapping method exists. So trace mapping method essentially take the advantages from the ECAD data. So the ECAD data usually used in electromagnetic analysis. So back in the day, ECAD data can be imported into structural analysis for structural and thermal analysis. But recently, I believe starting from last year, that technology also being adopted for explicit dynamic analysis as well. So yeah, effectively, it will mimic the structural behavior of the trace material inside this PCB without having to model the actual traces. Yeah, so ultimately this approach gives you the high level of accuracy or fidelity of the trace modeling, but without having to suffer the extremely long solving time. Because when you go with the trace modeling approach, the number of mesh is going to be skyrocket. It's going to take up until millions of number of elements, and therefore it's going to take a huge amount of time to solve those problems. But when we go with the lump approach, we sacrifice those accuracy for speed. Therefore, the result that we get might not be as accurate as we wanted it to be. And therefore, the trace mapping approach sits somewhere between those two, offer the benefits of both high speed, high accuracy ways or method to model a PCB. So actually, this analysis, this particular example is going to highlight that particular technologies of Ansys. So when it comes to setting up the simulation environments inside Ansys LS-DYNA, the workflow is pretty much straightforward, I should say. So here, as you can see, we have what we call as the workbench. So in this workbench, you have the ability to constructively lay down all of your analysis inside a single platform. It essentially enables the user to manage their project more easily. So here, as you can see, we have a different cells that serve its specific purpose. The first cell, or cell A, I should say, is where you import the CAD data of your PCB assembly. So with Ansys, you can import a variety of CAD format from multiple CAD software into the simulation environment. So no problem at all from there. So it doesn't matter what kind of CAD software you are using, you can import it directly into the Ansys environment. And then next we take a look at the cell C. Now the next cell, the cell C, is where we import the trace mapping data. The trace later on, when we import it into the Ansys environment, will be automatically mapped into our PCB model. And then subsequently representing the actual trace data from electromagnetic analysis. So such data can be retrieved from Ansys electronic products such as Ansys iSpec, for example. And then next, we move on to the cell B, which is where you do most of your analysis setup on, starting from material definitions all the way to the post-processing. So this cell is going to be where you spend most of your time on. Oh, I'm sorry. Okay. So yeah, the objective of this analysis, again, is to investigate the difference of approaches being used when modeling PCBs for drop test simulation. So this particular analysis, we are going to compare between the lumped or homogenized method and also the trace mapping method. These simulation conditions are as followed. As you can see on your screen, the drop height is set at 0.5 meter with standard earth gravity of 9.81 meter per second square. And then the slanted angle of the PCB is 45 degrees about X and Y axis. Material for the PCB and its component are as follows. For substrate, we use the polyethylene. For trace and vias, we use copper alloy. And the components on tops of the PCB, we use mold compound. Just for, for the sake of demonstration, we generalize the mold compound being applied to all of the I say all of the components on top of the PCB. So this particular PCB is a 10 layers PCB. The total mass of this assembly is around 32 grams. So not hugely heavy or not really ultimately light, somewhere in between, I suppose. And then the flow is set as rigid. Now I mentioned previously that you can set the material for where the device being dropped as well. But in this particular case, we just set it as rigid. That means no energy will be absorbed by the flow and all will be transferred into the PCB assembly. Rigid body is suitable to use when the difference in rigidity between the ground and also the tested device is significantly large. Because I assume that the difference in the rigidity between these two components is significantly large. Therefore, we go with the rigid body for the floor. One more thing is that because rigid body does not require elements in the body itself, when you mesh it, so it can save some simulation time. So here is the figure of the imported traces, represented by the density contour. So the red region, as you can see, is the region of high trace density, while the blue region is the vice versa. So the fidelity of the trace actually will depend on your mesh. So the finer your mesh is, the higher the fidelity or higher the accuracy of the trace is going to be. In this particular case, I say that the accuracy is okay. You can definitely opt for a higher level of fine mesh, but for this particular case, I say that it is quite satisfying. Yeah. Next, as for the meshing, in this case, a simple element size control was used to specify the element size for the PCB and also the floor. First, we set the global setting, which is 2 millimeter, and then the floor and the PCB was set locally at 5 millimeter and also 1 millimeter respectively. And then one thing to note is that in Ansys, there are a lot of mesh control that can be used to properly mesh your model. Sometimes your design is not going to be as simple as this particular PCB design. Sometimes when you involve in a design with many curvature, for example, like a car body or something, you need a proper mesh setup. And therefore, there are a lot of settings available inside Ansys for you to go through in order to get the desired mesh. Now, for this analysis, ultimately, the number of elements and nodes are about 260,000 and 230,000 respectively. Yeah, and next we specify the boundary condition. In this case, the important components that need to be set is the initial velocity. So using the drop test wizard that I shown you in the previous slide, the slanted angle was set at 45 degrees above X and Y axis, and then the drop height was set at 0.5 meter. So that gave us the impact velocity. Impact velocity means the velocity moment before touching the floor. So the impact velocity is given as the 3,131.5 meter per second, or about 3.13 meter per second. And then the flow will naturally be constrained in all directions. So we apply a constraint for our flow right there. Now, as for the result, we first evaluate the equivalent stress and contour plot of our PCB. Very straightforward. We just want to take a look at some of the von Mises stress or equivalent stress contour that has been happening on our PCB. So the left figure is the model that's been using the trace mapping, and then on the right is the model is the lumped or homogenized approach. So as you can see, the stress plot on the left, on the figures on the left, shows a distributed stress similar to the trace map of the copper alloy. So therefore, we can say that the upon impact, that the energy being transmitted mostly onto the trace of the copper alloy inside the PCB. And then as for the lump method or the homogenized method, one of the, on the other hand, does not quite capture all of the actual stress developed inside that particular PCB. Yeah, when comparing the stress contour to the trace map that I've shown you in the previous slide, you can see that most of the stress being developed at the region of high copper alloy density. Again, like I mentioned previously, the trace seems to be absorbing most of the energy from the impact. So from here, you can see the relationship between the stress contour and also the trace plot that we've just imported into our design environment. So just one more thing to highlight, because we use at the tip of this corner of the PCB, we can observe that there are a little indentation occur. This region of the PCB seems to be permanently deformed by about 0.08 millimeter upon impact. Because the material that we are using include the plasticity or the plastic region data of the stress strain curve, so such permanent deformation can be captured. Okay, so that is basically all for the example of Ansys LS-DYNA drop test simulations. And then next, I'm just going to summarize quickly. So essentially what we learned from here is that drop test has become one of the robust way to evaluate products' structural performance in electronics industries. Ansys LS-DYNA allow the engineers to thoroughly understand their product design and subsequently allowing for better product innovation without having to conduct physical testing. This will ultimately save a lot of time and cost in design and analysis process. And then furthermore, Ansys LS-DYNA also provide a complete product drop simulation program with a enriched or rich material model library and also easy to use simulation environment. Because Ansys LS-DYNA as well has been known as the industry standard for general purpose explicit dynamic solver. Therefore, Ansys LS-DYNA has a reliable reputation in the industries. Okay, so now before we wrap things up with the Q&A sessions, I would like to explain a little bit about our services here in CYBERNET Systems Malaysia. So here in CYBERNET Systems Malaysia, we can provide a technical service to anyone who is interested in starting up their CAE experience in their establishment. So basically our goal here is to help our customers to get a good and smooth start during the implementation of CAE into their way of working. So this service include a comprehensive startup service. We also provide you with a daily technical support service depending on the software that you are using. We can also provide you with the online-based learning platform, also known as the Ansys Learning Hub. Or we can also provide a standard operation basic training for the software, which can be done either, the training can either be done online or physical training, depending on the situation. And also provide a sample simulation for any specific target that fit our customers' need. So basically, our customer can essentially choose and combine these services according to their needs. Another part of our technical service is called engineering service. With this engineering service, our group of engineers can provide a simulation service for you. Essentially what it means is that instead of acquiring the software license to do a simulation, you can instead leverage simulation workload to us, and we can do the simulation for you. So this service is recommended to those who might be lacking of some time or maybe human resource at the establishment to do any kind of simulation work. So yeah, we can provide this analysis across the wide range of physics analysis and from any industries. So if you are interested in such kind of engineering service, you are more than welcome to contact us here in CYBERNET Systems. Okay, so I believe that concludes our webinar here for today.